Hello, welcome to the video on dimensional analysis. Again, I apologize here. For whatever reason, I'm not able to annotate when I'm in slideshow mode today. So we're doing a video from the normal PowerPoint view instead of slideshow view. So in this problem, we are asked to use dimensional analysis, and we are asked to convert the length of the average female human spinal cord of 43.0 centimeters over to feet. So this 43.0 centimeters, this is given. This is going to be my starting point in this problem. And I know that the dimensional analysis strategy requires that I have this set up with a label and as a fraction. So since that original measurement does not include a fraction, I put it over 1. We've talked about the strategy, so I'm going to put a multiply symbol and then another fraction bar to do my first conversion. My first conversion needs to cancel centimeters, and in order to cancel, those centimeters need to be in the denominator. So I will put that label where it has to be. I look over here in my list, and the very first one has centimeters. So I put the 2.54 centimeters on the bottom, and I put 1 inch on the top. The label of centimeters has been successfully canceled, and I now have a measurement in inches, but my goal was feet, so I'm not there yet. So I put another multiply sign and another fraction bar to do the next conversion. In this next conversion, I know that inches has to be in the denominator so that it cancels. And there's nothing else with inches on the list, so I have to think of what do I know? Well, I know that there are 12 inches in 1 foot. And so I'm going to take this information that I know and put the 12 inches in the denominator, the 1 foot up top, and that cancels inches. So the only uncanceled label is feet, and feet is the goal. So that means I'm ready to do the math. Now, in order to do the math, it is required that I multiply straight across. Okay, so I'm multiplying across the top. 43 times 1, I can do that in my head. I have 43. Multiplying across the bottom, well, I don't do that in my head. So graphing a calculator, 2.54 times 12 equals 30.48. So 30.48. Now, I've got to go one step further and actually divide them out. So again, on my calculator, 43 divided by 30.48 equals, here's a number. All right, so when I look at my original, it had 3 digits. We have no rounding rules at the moment, so I'm going to pick 3 digits, 1.41. And so I will say that this is 1.41 feet. As the course continues, we'll learn some rounding rules. But for now, follow the directions given in my lab, and when there's no directions like here, then you can decide how you want to round. It's your call. All right, so let's try another problem. So for this problem, it says, show your dimensional analysis. And it says, if you're going 65 miles per hour, what is your speed in feet per second? So this 65 miles per hour, this is our start. And one of the first things I notice in this is it's already a fraction. So when I write this, I can only put the 65 miles on the top of the fraction box. So 65 miles is the top, and hour is the denominator. Now, for some of you, it's uncomfortable that hour does not have a number with it, and so you may write the 1 that we've been putting in the denominator, but it does have to come with the label of hour because hour is clearly in the bottom of the fraction when the problem is stated. So I'm supposed to get to feet and seconds, which means I need to change both the top and bottom labels. I'm going to start on the top on account that it's on the top. So I put a multiply and a fraction bar. I'm looking in my list for miles, and it's the second one. So miles is on top, so miles goes on bottom. And I have 1 mile is 5,280 feet. So miles is canceled, top to bottom cancels. Feet is one of the labels I want. I will often circle just so I know not to keep looking for feet. That one is done. It's part of my answer. But our goal is also to get to seconds, and I have hours. So I'm putting another dot for multiply and a fraction bar. And the fact that these are not side by side does not matter. As long as I put them top to bottom, the multiplication and division will cancel. So on the top of this fraction, I have to have hours. There's nothing with hours in my list. So I have to think about, what do I know? Well, I know that 1 hour is 60 minutes. Okay, so I'll put that in. 1 hour, 60 minutes. Hours cancels, even though they're not next to each other. Top to bottom always cancels. And now I have minutes, but minutes is not what I want. So I'll put another dot for multiply and another fraction bar. Minutes goes on the top because I have to have it top to bottom to cancel it. Well, what do I know? I know that 1 minute is equal to 60 seconds. And so I'll put that in. So 1 minute is 60 seconds. So minutes is set to cancel. Seconds remains. And this is so cool. Seconds is in the denominator, which is what the goal was. So in our goal, we still have a fraction bar. We have feet on the top, seconds on the bottom. And when I look at what is circled, I have feet on the top, seconds on the bottom. So this means I'm ready to work at the math. So I multiply straight across. So grabbing my calculator here. Now let me clear this out from our last problem. Clear. All right. We want to type in 65 times 5280 equals. So 343,200. So write that down. 343,200. That's the top. Now I need to do the bottom. I've done this conversion before, so I know that's 3,600. And I want to show you something that we can do on our calculators, which is a little bit of a nice shortcut. So we talked about, and we will talk about using parentheses. So I can hit divided by, and then put a parenthesis, 60 times 60. So I have those two pieces in the denominator, and I can put that all at once. You see it's showing me that's 3,600, so I hit equal, and I get 95.3 repeating. And again, we have not learned any rounding rules, so we just get to pick. So I'm going to pick a whole number here because my original speed in miles per hour was a whole number. So we'll say that's 95 feet per second. But if you decided to go with 95.3 feet per second, you're good. There's no rounding rule. So just follow directions or make your own decision. When I write this answer, I can write this as feet per second with feet on the top and second in the bottom of that fraction. Or I can write this the way we would type, so 95 feet per second as the label that is separate from the number. And both are correct. So ideally, you would stop here and try the next problem on your own, but we're going to try it together. So if you want to pause, you can come back then after you've given it a try. So I look at the original, and it is not a fraction. So I will type 3,580 grams, and I will put it over 1 so that it looks like a fraction. I know that grams has to go on the bottom, and I look here, and here is my conversion. So 1,000 grams is the same as 1 kilogram, and that cancels grams. I am supposed to land in pounds, so I have to keep going. So kilograms has got to go to the bottom to get canceled, and I'm looking, oh, here's my next conversion. So 1 kilogram is 2.205 pounds. So that's a little more precise than we usually use in healthcare, but that's what I'm given, so I'm going to go with it. So kilograms is canceled, pounds was my goal, and so I'm ready to do the math. Now, when I look at this, I see the denominator is super easy. 1,000 times 1 is 1,000. And so I just need to do the little bit of math on my calculator. So we will go with 3580 times 2.205. That's the top. And then that will be divided by 1,000. And so we get 7.8939 pounds. And as we've talked about numerous times, we have not been given a rounding rule right now. So we'll just write this down and we would follow directions in my lab as how to write. So let's take a look at one last problem. And again, I encourage you to pause the video, try this on your own, and then check your work. So 236 milliliters is not a fraction, so I will put it over a placeholder 1 to make it look like a fraction. I immediately know milliliters has to go on the bottom because I need to cancel it. I look in my list and I have a conversion. So I put 29.57 milliliters is 1 ounce. And again, that's more precise of a conversion than we usually use in healthcare, but that's what we're given. Ounces is not my goal, so I set up my next conversion. Ounces is on top, so ounces has to go on bottom. That's the only way for it to cancel. Here's my conversion. 8 ounces is 1 cup. So as I look at the math, the top is the easy one, 236. I'm going to need some help from my calculator in the denominator. So clear. We have 29.57 times 8 equals, so 236.56. And I can see those numbers are really close, so my answer is going to be really close to 1. So doing the math, 236 divided by 236.56 equals 0.9976, basically 1. So 0.9976, etc., approximately 1 cup. So that is how you would set up these problems using dimensional analysis, using the conversions we're given, and practicing our strategy that always cancels things from top to bottom.